Welcome to This Explainer. Today, we're tackling a massive operational blind spot that cloud architects, database administrators, and IT ops professionals run into way too often. We're talking about diagnosing performance on your active DataGuard standby databases. If you've ever felt like you're just, operating completely in the dark when your standby suddenly bogs down, well, you're absolutely in the right place. Let's break down the architecture and the exact practical steps you need to solve this once and for all. So here's our roadmap for today. We'll quickly hit on active DataGuard capabilities, uncover the performance visibility trap, introduce the remote management framework, walk through configuring the UMF topology, and finally, generate those standby AWR reports. All right, let's jump right into Section 1, active DataGuard capabilities, specifically looking at how this fits into the maximum availability architecture. Now, Active DataGuard 19C is an absolute powerhouse for your reference architecture. It offers features way beyond a standard setup. We're talking active standby DML redirection, automatic block repair, and far sync for zero data loss at literally any distance. But the feature I really want us to focus on today is the read-only standby database. As ops teams, we rely heavily on this to offload those massive, long-running queries, heavy reporting, and backups from the primary. It's incredibly useful, but it does introduce a rather unique challenge. Which brings us to Section 2, the performance visibility trap, or as I like to call it, operating in the dark. Picture this scenario, because we've all been there. You've configured your active DataGuard, maybe you're using cross-region replication, you're perfectly utilizing that read-only standby for heavy reporting. But then, out of nowhere, things slow to an absolute crawl. The standby database is taking a massive performance hit. Naturally, as a database pro, your first instinct is to just grab an AWR report from that standby to find the bottleneck, right? Well, here is that classic pull-your-hair-out frustration DBAs have dealt with for years. You try to pull the standby AWR, but when you run the standard commands, the system deceptively generates a report based entirely on the primary database. It basically just forwards the request. So you end up staring at a perfectly healthy primary database report while your standby is quite literally on fire. You are left completely blind. Enter Section 3, the remote management framework. This right here is the architectural solution to our standby visibility problem. The crucial turning point here is Oracle Database version 12.2. Starting from this release, a brilliant feature dropped that finally opened the door to properly analyzing performance on ADG standby databases. For the first time, native AWR data could be captured directly for the standby itself, rather than just acting like a mirror for the primary. A real game changer. To make this happen, you've got to understand the underlying framework, and specifically, the hero of our setup, the SYSOUMF user. This is the default database user possessing all the privileges needed to access System-Level Remote Management Framework, or RMF, views and tables. Keep this user in mind because absolutely all AWR-related operations within the RMF can only be performed by SYSOUMF. It's literally the key that unlocks our performance data. All right, we know the architecture. Let's roll up our sleeves for Section 4, configuring the UMF topology. We'll walk through the step-by-step setup so you can actually implement this. Okay, Phase 1 is all about preparation. First things first, check the open mode and database role for both your primary and standby databases, just to make sure they're ready. Next, and don't skip this, that sys$fump user we just talked about, it's actually locked by default for security. You have to unlock it before deploying. Then you'll want to enable the hidden parameter _UMF remote enabled by setting it to true. Finally, create and really validate your bidirectional database links between the primary and standby. With prep done, Phase 2 is the actual topology creation. Start by assigning unique names to every database node in your topology. That's a strict rule, no exceptions. Next, execute the command to create the UMF topology itself. Once that's up, add your standby node into the setup using those validated DB links from Phase 1. And to wrap the whole shebang up, simply register the standby node for the AWR service. And that brings us to the payoff. Section 5, generating standby AWR reports. This is where all that configuration work actually bears fruit. With the framework fully configured and your topology live, those frustrating days of primary-only data are totally behind us. First off, you can now generate remote snapshots directly from the standby. Whenever you're ready to see the data, just run the good old ortrpt.sql script to extract your report. And what's really cool from an ops perspective, execution is supported from either the primary or the standby database. The framework just handles the routing seamlessly for you. If you're looking to deploy this and want the exact command syntax, definitely pull up Oracle Support Document ID 2409808.1. It has all the official, detailed documentation you'll need. So let me leave you with this thought. You wouldn't even dream of running your primary production database blind without AWR insights, right? So why are you still guessing about your standby's performance when it's out there handling your critical reporting and backups? By leveraging the remote management framework, you can finally gain total visibility and troubleshoot those cross-region bottlenecks with absolute precision. I really hope this explainer gave you the structural knowledge you need to turn the lights back on in your standby environments. Thanks so much for learning with me today, and I'll catch you in the next explainer.